Hello students! So this video here is on the lesson Translations with Function Notation. Alright, so guys, this is take two of this video, and my students who are enrolled in my classes, you should know exactly what I mean when I say this is take two of this video. Again, this video here is on translations with function notations. The previous lesson that we did was just sort of an introduction to your transformations and those types of transformations. And again, in this particular video, we're gonna discuss some more basics, but also we're gonna get into more specifically translations. Okay, so guys, before we get into some of the specific things that we want to include in today's lesson, let me just kind of mention that there was one thing, at least one thing that I neglected to mention in yesterday's lesson, and so let's kind of visit that briefly. Okay, so guys, that thing that I forgot to or neglected to mention in that previous lesson was the fact that isometries are sometimes called rigid motions. Again, guys, remember from that previous lesson that we had talked about what an isometry is, and we had said that an isometry is a type of transformation that preserves both the shape and the size. In other words, that isometry, it preserves the shape, meaning that it keeps all of the angle measurements the same, and it preserves the size. It keeps all of your side length the same, or keeps the perimeter or circumference the same. And again, in other words, isometry, an isometry is a transformation that will produce congruent figures, right? So when you have an isometry, that type of transformation, your pre-image and your image will be congruent figures. All right, so again, isometries are sometimes called rigid motions. All right, so guys, we're going to give you a little bit of basic information here before we start talking about the translations. This type of transformation, which is called translations, right? And before we start getting into all of the function notation that's involved here, there are sets of families. So our sets of functions, guys, and those sets of functions that we're talking about are called families. So there are sets of functions called families in which each function is a transformation of a special function called, excuse me, okay. There are sets of functions called families in which each function is a transformation of a special function called the parent. So again, guys, that's a parent. Okay. So there are special types of functions that we call families, and all of those functions in that family, guys, are going to be transformations of what we call the parent function. So guys, a parent function is the simplest form in a set of functions that form a family. So again, guys, when you have a family of functions, that parent function is going to be the simplest form in a set of functions that form a family. And again, guys, each function in that family is a transformation of the parent function. It's the same way that like, you know, normally, or I guess with humans, the same way you expect for offspring or children to sort of resemble or look like their parent, right? Their parents. You expect for children to look like and resemble their biological parents. It's the same way when we're talking about mathematic functions. When we have a family of mathematic functions, and all of those functions in that family are going to be transformations of that parent function. In other words, they're going to somewhat resemble that parent function. But again, there'll be some type of transformation of that. All right, so guys, since we're talking about parent functions, right? The simplest form in a set of functions that form a family. We need to make sure that you guys know something about some parent functions here. All right, so let's do this, okay? Because we need to make sure that you guys know, like really know some stuff about some parent functions. All right, so now guys, here I've got some, I repeat, some different types of function families, okay? There are a whole lot more types of function families. But again, here I've only got 6 specific types of families of functions listed, okay? So again, we don't have time to list all types of families of functions, okay? So we just got some of them listed here. All right, so here we go. We're going to introduce to some of y'all. We're going to present to others all of these, or at least some of these different function types. First up on deck, y'all, we got the absolute value function family. Okay, that was my way of trying to cheer for them. Yeah, absolute value function family. Okay, all right, enough of that. All right, so we got the absolute value function family here. And you can see that again, the absolute value function family, it has a specific parent function. The simplest form for the absolute value family is f of x, or y equals the absolute value of x. That is your parent function for all absolute value functions. You can see here that again, here they've got the graph of this parent function, y equals the absolute value of x, and you can see that pretty much, guys, all of your absolute value functions are going to look similar to that. They're going to have some type of V-shaped graph like that, okay? And again, folks, they've got a table of values here with not every single point that they could have, but here they've got some of the most critical points with graphing this parent function. They got the vertex of this parent function, which is excuse all of these bells. Yeah, you got to thank Pavlov for that one there, and all of his experiments with ringing bells. Anyway, here in this graph, or in this table, we've got the most critical points that are shown on this graph for the parent function of the absolute value graph. So we've got the vertex of that graph, which is 0, 0. And again, guys, you should know what a vertex is, just because we're not talking about a quadratic. Again, here, the vertex of an absolute value function is, well, for this parent function, this vertex is the is the relative minimum, or that point that's at the bottom, or the lowest point compared to all of the other points that are nearby. So the vertex here again is 0, 0, and then they've got these other points that are directly centered around that vertex in the table of values. All right, anyway, that's the absolute value function family. Next up on deck, y'all, we got the quadratic function family. Yeah! Okay, enough cheering. All right, so guys, the quadratic function family, we should already be familiar with that, because we've spent the whole unit talking about quadratic functions. We talked about how to solve quadratic functions, how to graph quadratic functions, how to factor quadratic functions. We talked a whole lot about quadratic functions. Different forms that quadratic equations can be written in: vertex form, intercept form, standard form. We did a whole lot about quadratic family, quadratic functions, okay? So here they've got the parent function for a quadratic function listed. They've got the equation here as f of x, or y equals x squared. Again, that is the simplest form for any quadratic function in that family. And again, guys, all quadratic functions have a U-shaped graph, and again, we should remember that those U-shaped graphs are referred to as parabolas. But anyway, that's the quadratic function family, and its parent function, as you can see here. Next up on deck, y'all, we got the cubic function family. Hey, all right. Okay, enough cheering. Now, guys, for the cubic function family, you can see the parent function here, f of x or y equals x to the third power, or x cubed, right? So again, guys, this one, you can see the type of shape of graph that it has, or the parent function has a graph that looks like this. And again, depending on what other transformations occur, the other graphs or functions in this family will sort of look similar to this one. And again, it has a table of values that shows some of the critical points involved in this parent function. And again, guys, we should know how to evaluate the functions and find the y values for certain x values, right? So again, yeah, you should know how to find the y value for the x value 0. So don't act like you surprised. Don't act like you don't know how to find these x and y values in this table of values if you're given that parent function f of x equals x to the third power. All right, we talked about evaluating functions and finding those y values when we're given x values. Anyway, next up on deck, y'all, we've got the square root function family. Come on down. The price is no, the price is not right. All right, anyway, so guys, for the square root family function family, they've shown here the parent function, which is f of x or y equals the square root of x. Again, guys, here we can see that the graph of this parent function, it sort of looks like half of a parabola, but it looks like a sort of like half of a parabola that's turned sideways or horizontally turned. But again, all square root functions are gonna look similar to the way that this parent function's graph looks, but they'll just have certain transformations done to them. Yeah. So that's the square root function family. Y'all gonna have to excuse all of these bells. Please excuse all of these bells. All right. That's why I like to start all of these videos after school is ended, so that you guys don't have to deal with all this. But again, this ain't the only video that I need to make for the day. So again, we remaking this video again because we had some technical glitches yesterday when we were trying to upload it. So again, next up on deck, y'all, we got the cube root function family. Hey, yeah. Okay, enough cheering. All right. So guys, for the cube root function family, you see here we've got the cube root. Again, it's a type of radical. Oh my goodness. Who ringing that bell? Again, guys, the cube root function family, you can see the parent function here, which is, and again, they've got here written y equals. We know that it could say f of x equals the cube root of x, right? So y equals, or f of x equals the cube root of x. Remember, guys, that this cube root is a part of that radical, a part of like all of your radical types of things. Remember that radical or type of root. This one has an index of 3. Again, the difference between this root and a square root is that the index for the square root is 2, even though that index is usually not written on the outside of the radical. But again, this radical for cube root does have an index written, and again, that index is 3, and it's a cube root. Okay. All right. So for this one, it sort of looks like the graph for this parent function sort of looks like looks like the cubic function turn sideways, right? So again, and we don't really have enough time for me to explain why it looks like the cubic function turned sideways, and it's really not turned sideways, not really. It looks like that because the cube root function and the cubic function are inverse functions. They're really reflections over the line y equals x. Anyway, we don't have time to go into inverse functions right now, so just take my word for it. Anyways, so again, guys, you see the parent function there. You see the graph. There's a little table there. Hopefully, you can kind of see that. I don't know. It's kind of small, but anyway. Next up on deck, we got the exponential. Wait a minute. Now, guys, it's important here for me to note that exponential functions, real talk, guys, exponential functions, they have different types of exponential functions. This particular exponential function that we're talking about here has a base of 2. All exponential functions have some type of base, and in the exponent, as part of the exponent, you're going to have the variable, the input variable or x included as part of that exponent. But again, this particular function family for exponential is focusing on the base of 2. Guys, if we changed the base here, it would be a completely different function family, a completely different exponential function family. But again, this exponential function family that we're talking about is one that has the base of 2. Okay, and you can see here that the parent function there is written as f of x equals, or y equals 2 as the base raised to the power of x. Okay, so again, guys, you can see a table of values that sort of kind of includes some of the most critical points for this particular parent function, for this exponential function with a base of 2. All right, and so again, guys, these are just 6 of some of the different types of function families. Again, guys, we don't have time to go over all of the different function families. I mean, there's so many more, guys. I mean, we got different types of piecewise functions. We got sine, cosine, tangent, logarithmic, inverse functions, different rational functions. We got a whole lot of different, function types and function families that we just don't have time to go over. So, but in this particular course, for my students who are enrolled in my class, okay, these 6 right here, we just kind of want to highlight these parent functions here for you. All right, and so, guys, we're going to, and I know that a lot of this probably looks abstract to you right now, but we're going to look at, examples with each type of function family that we've got here. And we're going to look at different examples of how those equations will look when we have those transformations. And again, we're going to look at that with the function notation. Okay, so guys, we're gonna start taking a little look here at the function notation that's involved with translations. And again, guys, remember that translations are types of transformations that are sort of like sliding or shifting in a vertical or horizontal or diagonally, where the figure is shifted or kind of moved, vertically, horizontally, or diagonally. But again, guys, now here there's something very, very important that you need to know just in general about function notations with any type of transformation. So guys, what I'm about to share with you really applies with every single type of transformation, okay? And this right here is a FYI, For those who don't know what that means for your information. This is something that's hot off the press. It's just for you, All right, so guys, all changes that occur inside of a function, f of x. Okay, so all of your changes that occur inside of a function, f of x, with the x, all of those changes inside of the function will be horizontal transformations. And again, guys, you're going to see exactly what I mean when I'm saying inside of a function. But again, any changes that occur inside of a function, f of x, will be horizontal changes. Now, we should know that horizontal is referring to left and right, right? Left and right, okay? That type of is left and right. But again, on the other side of things, however, guys, all changes that occur outside of a function will be vertical transformations. And again, guys, maybe something that could help you sort of kind of remember that is just kind of thinking about it like this. So the word inside, right? So when you're looking at changes that are happening inside of a function f of x, the word inside, it sounds a whole lot like input, right? Input. And we know, or we should know, that the input values, in other words, the x values in functions, those input values, they control the horizontal component, right? So those input values, or those inside values, input values, the x values, they're horizontal in nature. And so they're going to affect some type of left or right motion horizontally if you have changes inside the function. And again, on the flip side of that, those changes that occur outside, the word outside is sort of, at least the prefix of that out, right? It is the same as when we're talking about output. And we should know that for our output values in any function, we're talking about those y values or the function values for the output, right? Those y values or output values are always dealing with your vertical component. So again, guys, any changes that happen outside are always going to be vertical, and they're going to affect your graph somehow by moving it up or down, or it's going to be some type of transformation that deals with that vertical transformation, vertical component of dealing with it being up and down. Okay. All right. So again, guys, as you can see here, we've got this, and you kind of see where I've written here f of x, and you see here that the part inside of the function, the part inside of this function notation, the part inside the parentheses with the x is what we consider to be inside the function. Okay, the inside of it with the x, the input, right? Those are going to be those are going to be horizontal changes. And again, if you have anything that's written outside of the function, either on the left side or on the right side of it, but again, that's not actually inside the function with the x, then again, those changes are going to be vertical types of changes. Guys, here's another FYI for you. All right, so guys, those vertical changes that happen, so again, the vertical changes that are going to be occurring outside of your function, f of x, those vertical changes will always pretty much be very straightforward. And in other words, guys, they're going to be pretty much as expected. In other words, the way that you would the way that you would expect those vertical changes to be. And again, I'll explain that in just a second. I promise. And again, those horizontal changes are going to always sort of kind of seem counterintuitive or those horizontal changes that happen inside of the function are sort of kind of going to be the opposite of what you would expect them to actually be. Again, if you know anything about what horizontal changes happen on a coordinate plane and what vertical changes actually happen on a coordinate plane, then you sort of kind of will know what I'm talking about in just a second when we explain this. All right. So again, those vertical changes are going to be are straightforward, and as expected, the horizontal changes will be or will sort of kind of seem counterintuitive at first, and will sort of seem like they're the opposite of what you would normally expect to see for the horizontal part. Okay, so guys, let's take a look at the function notation for horizontal translations. So you can see here where we've got this thing, the function notations for horizontal translations, right? So that function notation is going to be where you have changes happening inside of the function with the x, right? And so again, not just any type of change, guys, but where you are adding or subtracting some number from the x, or adding some number to the x, or subtracting some number from the x. So you'll see here the general type of form for this function notation for horizontal translations looks like this: f of, and inside of the function, not only do you just have the x, but you also have x plus some number, or it will be x minus some number. Again, guys, we should know again that horizontal means that you'll be going either left or right, right? And so, guys, usually for those people who know anything about horizontal motions on a coordinate plane, right? So even if you're just thinking about the x values on a coordinate plane, usually for those who really know this, usually you would expect for positive x values, you would expect those positive x values to be on the right side, right? And you would expect those negative x values to be on the left side. And am I correct? Am I correct? Oh, I know I am. I just want to hear you say it. It's okay. All right. So again, guys, usually you would expect, and I'm going to erase this. I'm going to erase this after I write it. But again, guys, you would expect for the positive x values to be on the right side, and you would expect for the negative x values to be on the left side, right? On a coordinate plane. That's just what we would normally expect, right? For the x values, you would expect for positive to be right, and you would expect for negative to be to the left. Now, I've already told you in advance, guys, that those horizontal changes which occur inside of the function will seem counterintuitive. So guys, they are going to shatter they're going to shatter. Okay, yeah, I don't know what just happened there. Excuse me. Excuse that right there, y'all. They're going to completely shatter your expectations. They're going to completely shatter those expectations that you might have had. Okay? So again, guys, where you may have usually expected for negative x value to be to the left, and you might have expected for a positive x value to be to the right. Again, I told you that it's going to seem counterintuitive. So guys, even though we would expect for it to be like that, it's actually the opposite of what we would normally expect. So guys, for this function notation for the horizontal translation, if you are adding some number inside there with the x, it is going to be a shift or a movement to the left of h units. And if you are subtracting some number, then it is going to be a shift to the right by h units. And again, guys, I know that this completely shatters our normal expectation and is counterintuitive of what we would normally expect to see, like for our x values on a coordinate plane. But again, that's how it is when we're dealing with horizontal transformations. So when we add, or when this number inside there with the x is positive, and we're adding some number inside there with the x, that's going to be a shift to the left by that many units. And when we subtract some number in there with the x, that is going to be a shift to the right. Again, folks, I'm trying to let you know up front that this is the opposite of what you would expect, what you would normally expect, and it is counterintuitive, okay? But that's the way that the cookie crumbles. All right, I'm getting ready to erase that. So again, guys, that is the way the function notation works for your horizontal translations. And so let's take a look at the function notation for your vertical translations. So again, for that, we expect those changes, those vertical changes, to be happening outside of your function. So not on the inside of the function with the x, but outside of the function for the output values, right? And again, we know that those vertical translations are going to move it either up or down, right? And so, guys, this right here should be exactly the way you expect it to be. Again, if you were on a coordinate plane, you would literally expect for those y values, you would expect that the positive y values would be up, right? And you would expect for your negative y values or output values to be down, right? You expect for positive to be up. As far as for the y values, for the vertical component, you expect positive to be up and negative to be down. So again, guys, I've told you that those vertical changes are very much so straightforward. It's exactly the way you would expect it to be for the vertical changes. As expected. The exact way that you would expect it to be, okay? So again, guys, for your vertical changes, that's how it works. When you are adding some number, that's ugly. It's okay though. When you are adding some number on the outside, then it's going to be a shift up by that many units. And when you are subtracting some number on the outside of the function, then that is going to be a shift down by that many units. Okay, and it's going to shift. It's going to shift not only, and again, guys, it shifts the whole figure. But again, guys, it also, in order for it to shift the whole figure, the whole graph of the function, that means that it literally has to shift every single point. And again, guys, when I explain or when I show you how to do one of those delta math assignments, you'll see exactly what I mean. Anyway, so again, guys, that's the way that function notation works for your vertical translations. All right, and again, I'm going to go ahead on and erase. I'm going to go ahead on and erase that right there. All of that I just wrote from there. You go ahead on and just get rid of that. Get rid of that. Get rid of all of that. Bye bye. So long. All right. Great. All right. So again, that's the way your function notation looks. And again, guys, what you're seeing here is just the general type of way that it looks. We're going to look at examples where this h value on the inside, where it's actually numbers, and where the k value on the outside is actual numbers. And we're going to look at examples showing each of those different types of parent functions that I showed you earlier. So again, we're about to start looking at examples, and we'll try to show you different types of examples of how this actually looks with the function notation, and how those actual equations will be written when we write that. Okay, and then after we show you these examples, then we're going to show you how to do specifically how some of those delta math assignments work. for today's lesson, because for some of those it could be a little confusing because they may not have all of the directions written in that Delta Math assignments. And again, I'm talking to my students who are enrolled in my classes at our school. Okay, so guys, we're gonna again look at some examples now, and there's going to be 3 examples all together here. For each one of these examples, guys, we're gonna look at all 6 of those types of parent functions that I listed up before. We're gonna look at all 6 of it. So again, in each of these 3 examples, we're going to look at how the actual result of how the resulting function will look after we have done a specific type of translation. All right, so guys, for these examples, we're gonna be looking at again, f of x is going to be the parent function for the absolute value function family. G of x is the parent function for the quadratic function family. H of x is going to be the parent function for your cubic function family. J of x is the parent function for your square root function family. K of x is going to be the parent function for the cubic or cube root for your that function family. And M of x is going to be the parent function for the exponential function family that has a base of 2. All right, so in example 1, we're going to we're asked here to use the function notation to write the resulting functions after a translation of moving it right 5 units. After a translation of shifting it 5 units to the right. So, and again, guys, we're gonna look at each particular parent function that I've highlighted in this video. So again, guys, remember that if we're talking about moving right 5 units, then it's going to be, oops, and I didn't realize I had that written there. There we go. That's H. It sure is x plus a h, or plus or minus a h. Yeah, okay. Sure is. All right, because we're talking about a horizontal translation, is using this general form where we're adding or subtracting a number, where we'll be adding or subtracting a number inside of the function with the x. And again, guys, if we're talking about going right 5 units, again, for horizontal change, it's going to sort of seem counterintuitive or opposite of what we would expect. But again, guys, in order for us to do a shift or a translation right 5 units, this would have to be a minus 5. Okay? So right 5 would be us putting a minus 5 in here with the x. And again, I know that seems counterintuitive for something to the right being negative, right? Yeah, they just don't even sound right, Mr. Starkey. Going to the right, we have to put a negative number in there. But if you, and just kind of real quick, guys, if you guys remember, and we the next little example is going to be with the quadratic. But if you guys remember, for the quadratic functions, where we did the vertex form, and we had here that on the inside of that we had the little minus h and the plus k, and we told you that in order for you to identify the vertex, that you had to use the opposite sign of what was inside here with the x. Y'all remember that? So we told you that in order for you to identify the vertex from the vertex form, that you had to use the opposite sign. So it's not that different, guys, from what I had already told you, where you have to use the opposite sign of what's there, right? Where you use the opposite sign here. And again, I'm going to erase that because that ain't really what we're talking about here, but it is what we're talking about too. So again, guys, that's sort of kind of just a tribute to us talking about the vertex form with that. But anyway, guys, we'll be okay. Give me just a sec. All right. So again, guys, here we see that we've got the parent function f of x, and again here I just wrote that what the parent function was, the absolute value of x, right? And so if we're going to transform that and put in this particular translation of right 5, that means that we're changing the inside, so the inside of it is not just x, but now the inside is going to be changed where we're subtracting a 5 on the inside along with the x. So now the result for going right 5 should look like this: y equals, or f of x. Well, and again, I'm not putting f of x as to not so that I won't confuse you. But again, I'm writing y equals here. So that would be y equals x minus 5 as the result of how that would look if we change our parent function by performing a translation of right 5 units. It would look like this, okay? Next up, quadratic. Same way, same thing. The parent function of x squared. And again, if we're going to be moving right 5, that means that we're going to have to subtract 5 on the inside with the x. So that means that instead of it just, so guys, look here. Instead of it just being the x, that is squared, because again, guys, for the inside of this function, the part that is inside of this function is the part that is being squared. So instead of just x being inside of the function, instead of it just being x that is squared, now on the inside of the function, as a part of what is being squared, we've also got the minus 5, okay, inside of the function as a part of what is being squared along with the x, right? So now inside the function, we for that quadratic function, we should have x minus 5 and in parentheses squared. Now, guys, if you don't put the parentheses here, let me show you. Hold on. Let me show you wrong. If you don't put the parentheses here, and if you just put x minus 5 squared, like that right there, okay. If you don't put the parentheses, you are only, if you write it like this, guys, you are only squaring you are only squaring 5. Here you are squaring 5. So if you write it like that, it will be equivalent to x minus 25, literally. And again, guys, with the parentheses, it is definitely not x minus 25. So again, guys, I'm letting you know that you've got to write that with the parentheses for this quadratic function. Ooh, let me see if I can. Yeah, okay. See if I can. Yeah, there we go. Okay, yeah. Yep, okay. All right. So next up, h of x. Same thing, really, for the cubic function. Again, we've got the thing that's being cubed, and if you're going to change it so that we're translating it 5 units to the right, you got to change the inside. So you got to change the part that's being cubed on the inside. So moving 5 units to the right is going to be, instead of it just being x, it's going to be x minus 5. You should see the pattern in all of these. Okay, you should really see the pattern, and the only thing that's changing is the parent function itself. So again, instead of it, so in all of these, in the first one you have the absolute value of what's on the inside of it. Here, in the second one, you had this the part on the inside being squared. Here in the third one, h of x, you got the part on the inside being raised to the third power, and we're just changing the part that's on the inside, right? In j of x, this is the square root function. You should recognize the same pattern that we had in those previous examples. Again, the part that's inside of this function is the part that's up under that square root, the part that's being square rooted, the part that you're taking the square root of. Again, yeah, you should see the pattern, okay? In k of x, same pattern, got the exact same pattern for the cube root. Again, the part that's inside of the function is the part that's up under the cube root, the part that you're taking the cube root of. So again, instead of it just being x up under the cube root, when you do this transformation on the inside, now on the inside you're going to have x minus 5, and that's going to be the result of how it's going to look after you translate it 5 units to the right. And then the last one, for example 1, is this exponential function that has a base of 2. And again, for this one, again, the part that is inside of this function is the part that is your exponent. So again, the exponent, the part that is the exponent, is the inside of this function. So where your parent function only has x on the inside of the function as part of the exponent, when you change the inside of the function and subtract the 5 inside, now not only is x a part of that exponent, but also that now is going to be written as x minus 5 as a part of your exponent. Guys, this could be written with the parentheses or without the parentheses. I suggest you write it with the parentheses, especially if you're somebody who just writes like really big. Like if you write like really big, and it might be hard for somebody to tell whether or not your minus 5 is actually a part of the exponent. Like if you're gonna write it like this, then I suggest you write it using parentheses, okay? Because if you write it big like that, and we can't tell that you're actually writing something as part of the parenthesis, as part of the exponent. Okay, the way I've written it here, you can tell that this minus 5 is a part of the exponent, because I've got it written small and it's written above there, and it's written right there alongside with the x. But again, I suggest that you write that with parentheses. All right, next example. Example 2. All of these are going to have pretty much the same pattern too, guys. But again, with this, because this is a translation of down 7, again is going to be using that general form of plus or minus h. And again, guys, we know that for down, we expect for this to be for us to have to subtract some number there. Okay, so again, we're using that general form there, and we expect to have to subtract some number on the outside of that function, because this is a vertical translation only, and again, that's going to be some change that's happening outside of the function, and again, we're going to have to actually subtract some number here. So you're going to see the same pattern in all of these. So again, I've got each of these functions shown here for us doing this translation down. Okay, so this translation down for the absolute value, you can see the result here. There's not going to be any change that's happening inside of that function with the x, but the change is happening outside of the functions, right? So again, no change happening inside the functions, but only happening outside of the functions. All right, so that's how each one of these is going to look. So again, I'm not gonna waste the video time, the time here in this video by talking about all of this. I'm gonna zoom on along. You can see how these look. Okay, I'm gonna do it real slow. Zoom on along for you with the quadratic. You can see how the result's gonna look from the parent function to the result of it, right? So I'm gonna zoom on along with the cubic function. You can see how it's gonna look from the parent function to the result. If we're doing a shift of down 7 units, that change happening on the outside of the function, we're gonna zoom on along real slow, real slow, real slow. J of x, the square root function. Right? You see how that looks. K of x, the cube root function. You see how that's going to look from the parent function to the result of that. Ooh, see, I didn't even realize I hadn't even put no box around there. I didn't even realize that the first time I did that. Okay. Right, so you can see how that looks. You can see how it looks. Moving along. It's the exact same pattern where we're doing this shift of down 7 units. All these changes are happening outside of the function. It's not affecting the inside of the function with the x, but it's only affecting the outside of the function. Okay? And we're subtracting 7 outside of the function as the results here. Moving right on along here. For example 3, I kind of skipped over 2 of those because again, guys, the pattern is going to be really the same. The pattern is going to be the same. So yeah, again, guys, I skipped over for example 3. I skipped over the cubic parent function, or the cubic function, which is going to be something raised to the 3rd power, and I skipped over the cube root parent function because they're pretty much going to look similar to how we're seeing the quadratic and the square root thing. So again, because they have the same pattern, I kind of skipped over those parts, okay, or those 2 parent functions. But again, in example 3 here, we're asked to write the resulting function and state which specific translations have occurred. So we're asked to write the resulting function and state which specific translations have occurred. So guys, in part A here, we're asked to find the f of x and plus 13 on the outside, right? And we're asked to do that transformation if f of x is the absolute value of x, right? So again, So again, guys, they're giving us the parent function f of x, which is the absolute value parent function, and then they're asking you to perform that particular transformation. So if we're adding 13 on the outside, that's going to be the translation of up 13. And again, the way that the result of that equation is going to look is y equals the absolute value of x plus 13 on the outside, right? All right. Here in part B, if we've got g of x as the parent function, and again, guys, that was the quadratic parent function, and if we're asked to perform this transformation where we're adding 4 on the inside and subtracting 1 on the outside, again, guys, that's going to be the translation of, it's going to be a diagonal translation, both vertical and horizontal, but again, it's going to be based on the adding 4 on the inside, that's going to be us moving left 4, and based on us subtracting 1 on the outside, that's going to be moving down 1. So this is going to be a combination of moving left 4 and down 1. And again, the way the equation is going to look as a result of doing that translation of left 4 and down 1 is again where you add 4 on the inside of that quadratic function and you subtract 1 on the outside of it, and that's gonna be where the parent function, or where the image now it has been moved left 4 and down 1. Okay. All right. So part C again, it's the same pattern. Really, yeah. If we're dealing with h of x, which is that square root function, and we're asked to find this transformation where you're subtracting 2 on the inside and adding 1/2 on the outside, then that's going to be us moving right 2 based on what's happening inside of the function with the subtracting 2 on the inside. That's going to be moving right 2, and it's going to be moving up 1/2 unit. Okay, based on the adding 1/2 on the outside. So again, the result of that equation, if it's a square root parent function, then the way that that's going to look, if we do those transformations of right 2 and up 1/2, is going to be us doing this is going to be y equals the square root of x minus 2 on the inside, and then the plus 1/2 on the outside, right? And then, guys, this last example that we showed here is with the parent function m of x, which was that exponential parent function of with the base of 2. And so if we were subtracting 7.5 on the inside and also subtracting 3 on the outside, then that would be us moving right 7.5 units and down 3 units. So again, guys, the way that function would look as a result, so again, the exponential function with the base of 2, again, we've already talked about what the parent function is, but the way the result would look if we did those two translations, right 7.5 down 3, is it would be y equals 2 as the base raised to the power of x minus 7.5, and again, that's on the inside as a part of the exponent, okay? And then on the outside of the function, minus 3. And the minus 3 is not a part of the exponent, okay? Only the x minus 7 is a part of the exponent. Sorry, x minus 7.5, right? All right, so those are all of the examples that we're going to do here. Guys, again, I wanted to make sure that I showed you how to do the Delta Math assignments, and I am going to do that in just a little moment. In just a brief moment, I'm going to show you how to do that. But I do want to make mention, guys, that some of the Delta Math assignments that I'm going to show you again to make sure that you know exactly what it is or how you are to complete it. Some of those Delta Math assignments, and I'm talking to my students who are enrolled in my classes at our school. Again, some of those Delta Math assignments will have it so that you're going to have to actually click and drag some of those points. So guys, again, if you're going to be clicking and dragging some points, then I want to make sure that those of you who are using your cell phone, and on your cell phone, you're going to have to use some type of internet browser on your cell phone. I want to make sure that you guys know that the best way for you to do this on the cell phone is, if you're doing Delta Math on your cell phone, the best way for you to do this is for you to change that desktop, is to change it to a desktop mode, or to request a desktop website on that internet browser. So guys, if you are on some type of Apple phone and you are trying to do a Delta Math assignment, so let's look here, right? If you've got a Apple phone with an iOS version 12 or below, then you're going to need to tap and hold that refresh button. When you do that, you'll have to click on the part that says request desktop site. And again, guys, I'm letting you know that it's going to be easier for you to do your click and drag on a cell phone if you change that website, if you change it to a desktop version. Instead of it being on the mobile version, it's going to be easier for you to do this Delta Math with the click and drag if you change it to the desktop website, okay, or to a desktop mode or desktop version. Guys, if you're using an Apple phone with an iOS version of 13 and above, or 13 or above, then you're going to need to tap on that double A. That's right there. I think that's the thing that you tap if you want to change the font size of your browser. Again, guys, when you tap on that double A, also what you're going to see is you're going to see that request desktop website. And again, that's how you'll have to, of course, click on that in order to change it to a desktop version. And I'm letting you know this to make your life easier when you're doing this Delta Math assignment if you're doing it on your phone. So guys, that's how you would do it if you have an Apple phone. And a lot of Apple phones by default have the Safari internet browser. So if you're doing a Safari internet browser on an Apple phone, okay, that's how you'll do it. Okay? Don't say I didn't try to tell you. If you are using a Google Chrome, and I'm not sure whether it's going to be different on an Apple phone or iPhone or Android phone, but if you're using Google Chrome, I think it will sort of kind of be pretty much the same on any type of device, whether it's Apple or Android, if I'm not mistaken. I'm not sure. Don't quote me on it because I'm not really too sure. But if you're using Google Chrome as your internet browser and you are doing Delta Math on your phone using Google Chrome as your internet browser, you are going to want to tap on those three dots in that internet browser for the menu. I think the technical term for those three dots is a kebab. Yeah, don't ask me why they call it a kebab, but again, you'll have to click on those three dots there. All right, so you'll click on those three dots and you'll see up there, request desktop site. You will have to click and check that box in order for it to change it to that desktop website for Delta Math. Okay, and again, guys, I'm letting you know this so it will be easier for you to do any of the click and drag, where you will have to actually click and drag some things in Delta Math. Okay, next up, guys, if you're using Firefox on, okay, so we've got two versions of you using Firefox, right? If you're using Firefox on an iOS or Apple phone, right? If you're using Firefox on an Apple phone, which has your iOS operating system, your iPhone type of things, right? Then you're gonna click on the kebab, and I think it's really mostly pretty much the same. You'll click on that kebab, those three dots that's up there. For the most part, it's pretty much the same for whether you have an iPhone or Apple phone, or at least that's the way that Google explained it, and the way I got these pictures from when I Googled how to do it. So if these are wrong, then we can blame Google, or we can blame it on me not looking at every particular thing that Google said. But guys, again, if I'm wrong about how to change this to a desktop site, please feel free to Google this on your own and pull up your own results. But I've been kind enough to show you this here. Next, guys, again, I'm going to show you exactly how it is that you're going to need to do those Delta Math assignments for today's lesson. Let me see here. Y'all don't need to see me logging into Delta Math. Hold on. Okay, so guys, this is how one of the assignments that you guys are going to need to do on Delta Math for today's lesson. And again, I'm talking to my students who are enrolled in my class, again, at our school. This is how one of those Delta Math assignments is going to look. And they say here, translate the figure 2 units left and 4 units down. Here, of course, in this assignment, they're not using function notation, but again, they want you to translate. Now, guys, read the directions, because this particular assignment does have directions on how you need to do this, right? And it says, plot all of the points of the translated figure. You may click a plotted point to delete it. So, first off, you'll click the point to plot it. So let's say that I wanted to translate this point, right? Let's say I wanted to translate this point. And they say translate 2 units left and 4 units down. 2 to the left and 4 units down. Y'all see that? 2 units left and 4 units down. I will click on it. Boom. That's 1 point. Boom. Now, guys, again, you're going to need to do that with each of these points that they have here. Okay? So you'll need to do that. 2 to the left, down 4. Whatever. 2 to the left, down 4. Okay? You need to make sure you do that. 2 to the left, down 4. 2 to the left, down 4. Whatever. Alright? 2 to the left, down 4. 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 What I miss? What I miss? What I miss? What? That ain't it. Okay, because it made it look wrong. There we go. And then 2 to the left and down 4. There we go. Alright. So again, guys, you can see you can click on a point to erase it. You can click on a point to put it there, right? So again, once you got it the way you want it to look, for this particular one, then you click submit, okay? That's not hard for you to do. Alright. Next type. The next type of problem set. Let me go to that. Y'all don't need to see me go on to that. Hold on. Okay, so guys, another type of your problem sets that I've assigned for today's lesson on Delta Math is going to look like this. And you see here, guys, they've got this function, and they don't really have any instructions here, right? And I know it says translate functions, but they don't really have any instructions. So that's why I wanted to show you this particularly, so that you know exactly how it is that you need to do this. So guys, with this type of problem set, where they want you to translate the function, they already have the parent function of this quadratic function here. They already have the parent function graphed. So what you're seeing here, this graph that's already up there, that is the parent function, or the graph of the parent function. And guys, what you're going to have to do here is you're going to have to click and drag at least one of these points to make sure that you're doing it the right way. Now, guys, here's the deal. I'm gonna go ahead on and Lord, I sounded like Joe Biden. Here's the deal. Anyway, okay, we're gonna have to click and drag some of these points. So now, guys, it will let you click and drag any of these points. So like now, so it will let you do it wrong if you want to. Like literally, it's gonna let you click and drag any of these points. But I'm here to let you know that for this particular type of transformation, for a translation, listen carefully, for translation, the point that you're going to want to click, hold, and drag is going to be the vertex. Now, guys, you should know what the vertex of this is. Now, depending on what type of function it is, it may not have a vertex, but I'm going to go ahead on and give you the trick for this type of problem set. Guys, for this problem set, for this type of problem set where you're asked to perform this translation, you're going to want to click, hold, and drag the green dot. Not any of the blue dots or any of the other colored dots, but the green dot. You're going to want to click, hold, and drag the green dot. Okay? And so, guys, you're going to want to move and click, hold, and drag that green dot for you to shift it whichever way that it needs to be shifted. Now, guys, just really quickly, right? Because, again, we've talked about this. If the parent function for this quadratic family is y equals x squared, and you see the change here that's happening is that it's added 3 on the inside, right? So there's been a 3 that's been added to the inside of this function. So if it's added 3 on the inside, that means that it's going to be either left or right, right? So which one goes against your better judgment of what you should already know about the x values on a coordinate plane? Which one goes against your best judgment? And what did we say, right? That it's going to kind of be the opposite of what you would normally expect. Even though we see that positive x values on the right side, right? We need to do the sort of the opposite, and sort of is going to be counterintuitive. And so the way that this is going to be shifted is to the left 3. So you're going to click, hold, and drag the green dot, and you're going to click and drag it whichever ways you need to. Some of them might be only horizontal. Some of them might be only vertical, where you're just moving up or down. And then other ones might be a combination of both vertical and horizontal, where you may have to move it like right and up, or right and down, left and down, or left and up, right? So again, you're going to click, hold, and drag the green dot for this particular type of thing. Now, don't act like I didn't tell you. Again, now, if you decide on your own to ignore my video instructions here of me trying to show you how to do it the right way, if you want to sit here and click and drag some of these other dots to do something else, then you on your own. Because again, I'm trying to show you how to do this the right way. So again, ignore my instructions at your own peril. Okay, but again, I've tried to show you how to do this the right way. All right, again, guys, that's pretty much it. That's each different type of problem set there. So again, for the first type of problem set, you'll have to click it. You just have to plot those points by clicking on where you want it. And then for the second type of problem set, you'll have to actually click, hold, and drag the point. And again, I'm letting you know, click, hold, and drag the green dot. Click, hold, and drag so that you can translate this thing, okay? Alrighty, that's it. Again, we've talked about the function notation and translations using function notation. And again, I tried to also make sure that you know how to do these particular assignments. I tried to make it so that if you're using your cell phone to do these Delta Math assignments, that you also that you know exactly what's going to be the easiest, probably the easier way for you to use your cell phone if you got no other choice and you got to use your cell phone to do these Delta Math assignments. With that, I tried to make sure you know how to change that internet browser into a desktop mode to make doing this easier for you. Alright, that's it. I hope that this has been helpful. Again, folks, this is my second time having to make this video. Again, I've explained to my students, again, that there was a glitch that happened the first time. I do hope that this has been helpful to you. Yeah. Alright, that's it. I gotta make another video. Bye.